Good morning, students. Welcome back to the maths class. In our previous class, we learned about the types of functions. That the very first one is identity function, second one is a constant function. In this class, we are going to start with a modulus function. Modulus function is an important one for your point of examination for 5 marks, very important one. Kindly do not neglect. What about a modulus function? How we are going to define a modulus function? I think you already have a little bit idea about the word modulus. Modulus is nothing but modulus of -1 is a +1, modulus of -2 is a +2, modulus of -3 is a +3, right? Like that, we are going to define this modulus function. And also we are very familiar with the word modulus. Here we are going to draw a graph for the modulus function. Okay, here we are going to discuss about a function which is a modulus function. Let us define this modulus function. A function f from R to R. R is nothing but a real number. This also represents a real number. We know that it is a domain and it is a codomain. We are going to find a range for this function also. A function f from R to R is defined by f of x equals to, you just think how we are going to define this modulus function. Modulus, what is the symbol for modulus? This represents a modulus. Is defined by f of x equals to modulus of x. For all x belongs to R, where x must be a real number, is called a modulus function. It is the definition for this modulus function. A function f from R to R, a function f from real numbers to real numbers is defined by f of x equals to modulus x for all x belongs to R is called a modulus function. Let us draw a graph for this function. Before that, in this we have one more point, that consider f of x equals to modulus x. You just observe modulus of x, there will be a positive and negative also, isn't it? One positive, one more, that is a negative. F of x equals to modulus x. Modulus represents a plus or minus. For that plus or minus, we will get two cases, plus x one case, minus x one case. It is x if x should be greater than or equal to 0. F of x equals to modulus x, f of x equals to plus x, positive x, when x should be greater than or equal to 0. That means the values should be more than 0. This represents the values should be more than 0, including 0 also. Including 0, more than 0, then we will get to plus x, I mean the positive values of x. Now it is negative, minus x, when it is negative if x is less than 0. This represents lesser values of 0. Hence it is the definition for this modulus function. Let us draw the graph for this function. Before that, draw the table for this function. It is x and it is f of x equals to modulus x. Just draw the table. it is minus 5. Let us take the values on x-axis. Minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5. Now here we are going to applying a modulus function. Let us put the values. Let us substitute the values of x in this f of x equals to modulus x. Then what we will get? Modulus of minus 5. Modulus of minus 5. Modulus of minus 5 will be plus 5 only. Modulus of minus 4, that will be plus 4. You just apply the modulus for these values. Modulus of minus 5 is plus 5. Modulus of minus 4 is plus 4. Modulus of minus 3 is plus 3. Modulus of minus 2 is plus 2. Modulus of minus 1 is plus 1. Modulus of 0 is 0. Modulus of plus 1 is plus 1. Modulus of plus 2 is 2. Modulus of plus 3 is plus 3. Modulus of plus 4 is plus 4. Modulus of plus 5 is plus 5. Hence, it is the table for this function. Let us draw the graph for this modulus function. You just see the table. Let us take the values on positive at x-axis. It is origin 0, 1, 2, 3, 4, 5, 6 and so on. Let us take the values on negative x-axis. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6 and so on. Let us take the values on y-axis, positive y-axis. 1, 2, 3, 4 and 5. Let us take the values on negative x-axis, negative y-axis. Minus 1, minus 2, minus 3, minus 4 and minus 5, minus 6 and so on. You just see the table. Let us draw a graph for this function. If x equals to 0, if x equals to 0, then modulus of 0 is also 0. If x equals to plus 1, also f of x equals to plus 1. If x equals to plus 2, y equals to plus 2. If x equals to plus 3, y equals to plus 3. If x equals to plus 4, y equals to plus 4. If x equals to plus 5, y equals to plus 5. Now, if x equals to minus 1, then y equals to plus 1. If x equals to minus 2, then y equals to plus 2. If x equals to minus 3, then y equals to plus 3. If x equals to minus 4, y equals to plus 4. If x equals to minus 5, then y equals to plus 5. You just join these points with the help of a scale. Finally, we will get a graph for the modulus function. I am just joining these points. Hence, it is a graph for the modulus function. Now, what about domain, codomain and range will be? What about the domain, codomain and range will be? Domain, codomain and range. Domain. In the definition itself, we have domain, codomain. You just observe the definition for this modulus function. There we have defined, there we defined that a function f from R to R is a real number, R is also a real number. Therefore, domain is a real number, domain is a real number, codomain is also a real number. The function is called Signum function. Now next type of function, that is a Signum function. How we are going to define a Signum function? Hence, Signum function is also important for your point of examination. Also, it carries 5 marks. Write down a definition for this Signum function. A function f from R to R. A function f from R to R. We know that R is a real number, R is also a real number, and also this one represent a domain, this one represent a codomain. Then for a Signum function also, the domain and codomain will be a real numbers. A function f from R to R is defined by f of x equals to here we have 3 cases, 1, 0, minus 1, 1, 0, minus 1. If x greater than 0, that means higher values of 0, that means a positive values. X is greater than 0 is nothing but a positive values. If x equals to 0, second case, that is 0 if x equals to 0. Third case, if x is less than 0, that means what? Negative values. If x is positive, we should take plus 1. If x is negative, we should take minus 1. If x equals to 0, we should take 0. Once again, if the value of x is positive, we have to take plus 1. If the values of x is negative, we have to take minus 1. Or if it is equals to 0, then we should take 0. Let us draw the table for this function. And also you just observe x greater than 0, x equals to 0, x is less than 0. X greater than 0 is nothing but 0 is excluded. X is less than 0. Here also we have one more condition, x less than 0, x greater than 0, x equals to 0. If x is positive, we should take 1. If x is negative, we should take minus 1. If x equals to 0, it is 0 only. Let us draw the graph for this function. Before that, let us draw a table. Let us draw a table. By using the table, we are going to draw a graph. It is x and it is f of x. F of x is nothing but y. If you want to take, you can take y equals to f of x. In place of f of x, you can write it as y. Let us take the values on x-axis will be minus 5, minus 4, minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3, plus 4, plus 5, plus 6, plus 7, and so on. Now, suppose I already told you that if x is negative, whatever the number it is, if x is negative, we should take minus 1. If x is positive, we should take plus 1. If x is equals to 0, then we should take 0. If x equals to 0, if x is 0, then f of x equals to 0. If x equals to plus 1, whatever the number it will be, if it is a positive number, we should take plus 1 only. For all the positive values, we should take plus 1, 1, 1, 1, 1, 1, right? If the values, if the values of x is negative, is minus 1. Whatever the value it will be, if it is negative, we should take minus 1, minus 1, minus 1, minus 1, minus 1, minus 1. For all the negative numbers, the output value will be minus 1. For all the positive numbers, the output value will be plus 1. If it is equals to 0, that output value is also 0. Hence, it is a table for this function. Now, by using this table, let us draw a graph. Let us draw a graph for this function, Signum function. It is origin, it is x-axis, and it is y, it is negative x-axis, and it is negative y-axis. Let us take the values on x-axis 0, 1, 2, 3, 4, 5, 6, and so on. The values on y-axis 1, 2, 3, 4, 5. The values on negative x-axis minus 1, minus 2, minus 3, minus 4, and minus 5. The values on negative y-axis minus 1, minus 2, minus 3, minus 4, and minus 5, minus 6, and so on. You just see the table for this function. I am going to draw a graph for this function by using the table. If x equals to 0, f of x is also 0, right? If x equals to plus 1, then f of x equals to plus 1 only. If x equals to plus 2, f of x equals to plus 2 only. If x equals to plus 3, f of x equals to plus 3. If x equals to plus 4, f of x equals to plus 4. F of x equals to plus 1. If x equals to plus 5, f of x equals to plus 1. If x equals to plus 6, f of x equals to plus 1. If x equals to 7, plus 1. If x equals to 20, plus 1. If x equals to 100, plus 1 only. If x equals to 200, plus 1 only, like that. Now, if x equals to minus 1, then y is also a minus 1. If x equals to minus 2, then y is also minus 2. If x equals to minus 3, then y is also minus 3. If x equals to minus 4, y is also minus 4. If x equals to minus 5, y is also minus 1. Okay, whatever the value it will be, for all the negative numbers, we should take minus 1. For all the positive numbers, we should take plus 1 only. If it is equals to 0, it is 0 only, right? And one more thing, the symbols in this graph, we have to represent the symbols. These symbols you are going to learn in the first chapter, that first chapter called sets. This symbol represents excluded. This symbol represents included. There is a difference between these two symbols. About these symbols you are going to learn in your first year, in your first chapter. The chapter is sets. These symbols I am going to draw in this graph. Here we are going to join these points. Before that, if x equals to 0, then y is also 0. Is nothing but here 1 is excluded. Okay, you should represent this symbol properly. Similarly here also, if x equals to 0, then minus 1 is excluded. Kindly you just draw this symbol properly in your notebook. If you make any kind of mistakes while writing these symbols, 100% you will lose your marks. Now let us join these points. Let us join these points. Join these points. Finally, we will get a graph for this function. It is excluded, so that do not join this one. Now, if x equals to -1, you just join all these points. Once again, this symbol represents excluded. It is also represents excluded. Hence, it is the graph for Signum function. You just draw this graph in your notebook with the help of a graph sheet. Kindly do not make any kind of mistakes in your notebook. You just see the difference in between these 2 points. This symbol represents excluded symbol. This symbol represents a excluded symbol. All these are the points. These are the points. Make sure you just bubble it properly. Hence, it is a graph for Signum function. Now we are going to write the domain and codomain for this function. What about the domain and codomain for this Signum function? Domain and codomain. I already told you in the starting itself that the domain and codomain will be a real numbers. The domain and codomain will be a real numbers. What about the range? What about the range? Range is nothing but the outputting values of f of x, isn't it? You just see 0, 1, 1, 1, 1, -1, -1, -1, -1, -1 we will have, right? Range for this function also 0, -1, +1. You just see the definition for this function. Here we have 1, 0, 1, 1, 0, 1. 1, 0, 1 will be a range. 1, 0, 1 will be a range. -1, 0, 1 will be a range. -1, 0, 1. Apart from these 3 values, we are not getting any kind of other value. So that -1, 0, 1 will be a range for this function. Hence, it is a Signum function. The question may be asked like this: define a Signum function, draw the graph for the Signum function. Also, write down the domain, codomain and range for this Signum function. Like that, the question will be there. You just practice 3 or 4 times at your home, then you will be perfect in these types of functions. Hence, it is the class for today. In the next class, we will continue with the other type of function. Thank you.